Hello, everyone. Welcome to UC Davis Healthy Soils Project workshop. Thank you for being with us. And I'm Rui-Hong Zhang. I'm professor in the Department of Biological and Agricultural Engineering at UC Davis. And I am the principal investigator for this project. We wanted to share our research resource with you. And the project is dairy manure compost products for healthy soils in almond orchards. So I would like to welcome you again, and I will introduce the agenda, go over the schedule for this morning. We have scheduled for 2 hours, and and we have our sponsors, speakers from sponsors to give their presentations and the remarks, and also have a research team to present the research conducted and also key findings and the conclusions I want to share with you as a part of this healthy soil project. And so now we'll have Q&A, and we hope to finish this workshop by noon. And I will be the chair of the workshop and also MC for the workshop. I will be working with our speakers and keep the program going, and I will be managing the Q&A as well. And so for our audience, and your video and the mics are muted, and so we and you can type your questions in the QA. If you just open the QA, you can type questions there, and then we will be able to answer as we go. And if we have time after each session, and then we will answer questions as well. And so have our panelists to answer questions as we go. And we will have some time in the end to address questions that are not answered during the workshop. And we will be conducting short surveys. One is now, and also one at the end of our workshop. And so the purpose of survey is to find out your interest, and also so that we can provide more information to you after the workshop. And also I would like to get your input, feedback for our workshop and the project, the findings, research results we have shared with you. And so now I wanted to introduce Abdul Hossein, we call Hossein Idalati, and Hossein is a PhD student working with me and as a lead researcher on this project. And so have him to tell us about the survey, and he will be speaker presenting research as well. And so also I wanted to thank Almond Cho, who is a PhD student working with us on this Zoom webinar. And I wanted to thank College Engineering of UC Davis for hosting this webinar. Hossein, please.
So if you are on this as an attendee, if you could enter there's a Google form that we've created for the pre-survey. You can either access it using that link that I submitted by the chat, or you could use your smartphone and access it using the QR code. It's 3 to 5 questions. There's several questions that are farmer specific. So if you are not a farmer, just answer not applicable. Thank you.
Yeah, if you can use the QR code or that link and to complete the survey, short survey. We'll give you a little bit time. Okay, we'll keep our program going. And so the title of our Healthy Soil project jointly it's, well, I will talk about our sponsors. So the title of our project is Production and Application of Compost and Pelletized the Compost Products from Dairy Manure and Almond Woody Biomass and California almond orchards. This research was jointly funded, sponsored by 3 agencies in California Department of Food Agriculture, Healthy Soil Program, and the California Dairy Research Foundation, Almond Board of California. And so I wanted to thank them for sponsoring our research and providing funding and the support for our research. And so I wanted to introduce the speakers from our funding agency, our sponsors, and these individuals have been working very closely with myself and my research team, and from standpoint of project management, grant management, and they also have been very closely involved in our research activities as well, and by providing the support and also guidance and helping finding the research sites for our experiments, and we really appreciate their support. So I'd like to introduce the first speaker. Is Elizabeth Hassan from the California Department of Food Agriculture. Elizabeth has been the project manager for CDFA funded the project. And so Elizabeth is a senior environmental scientist. And so she works with the Healthy Soil Program in the California Department of Food Agriculture within the Office of Environmental Farming and Innovation. And she has worked for State California for over 7 years on different greenhouse gas emission reduction, habitat restoration grant programs. And with that, I will welcome Elizabeth to join us.
Thank you for that introduction. I'm going to share my screen. All right, you should be able to see my screen now. So I'm going to be giving a, as introduced, my name is Elizabeth Hessam. I work for the California Department of Food and Agriculture for the Healthy Soils Program, which helps fund the research that we're going to be hearing about today. I'll be giving a brief overview about the program, the grants available for any attendees curious about the Healthy Soils Program itself. So I'll be giving a brief outline of the office that houses the Healthy Soils Program, as well as the program itself, the grants that are available, future solicitations, and then I'll open it up for questions. We also might take questions at the very end after all the sponsors have given their remarks, so we might hold questions till afterwards. So the Healthy Soils Program is under the Office of Environmental Farming and Innovation at CDFA. And this office has a host of different programs that we offer that help incentivize practices that help benefit the environment through innovation, efficient management, and science. And you can see on the slide there's a number of different programs that we have, which include programs that help incentivize water efficiency and alternative manure management, just as an example of a few of them. The Healthy Soils Program itself stems from the California Healthy Soils Initiative, which is a collaboration of a number of different state agencies on this measure. And the program has 3 different types of grants that we offer, 2 which are established and 1 which we're currently developing. The first is our Healthy Soils Incentives Program, which provides financial assistance for implementation of conservation management practices that improve soil health, sequester carbon, and reduce GHG emissions. Our second type of project are the demonstration projects, which we'll be hearing about today. And these type of projects focus more on the research component, data collection, greenhouse gas emission quantification, and there are also outreach component to them. Our third type of grant, our new block grant pilot program, which we're currently developing, is going to have a similar structure to our incentive grants. However, the eligible recipients will disperse grants on behalf of CDFA to eligible farmers and ranchers. And I'll go into that a little bit more in a bit. For our incentive grants, eligible entities are California farmers, ranchers, and federal and California recognized Native American Indian tribes. There's a couple of different requirements for these grants, which you can see listed on the slide, but I want to focus on the fact that these grants are 3-year grant terms, and recipients should be taking soil organic matter tests every year to help show the improvement in the soil during practice implementation. The program funds a number of different practices, as you can see on the slide. This is a breakdown of the Healthy Soils program spanning from 2017 through 2020. And you can see our most popular practices are compost application, cover crop, and hedgerow planting. But we fund a number of different practices, as you can see visible on the slide. All of these practices are based on the Natural Resources Conservation Service Conservation Practice Standards, or CPSs. Through the life of the program so far, not including this most recent funding cycle that we are concluding sending out our awards for out, which would be the 2021 fiscal year, from 2017 through 2020, we funded a little over 600 of these projects with total greenhouse gas reductions at about 109,000 metric tons of CO2 equivalent benefits, and then covering a total practice implementation acreage of a little over 51,000 acres. For our demonstration grants, you can see the eligible entities listed on the slide, which are different from our incentive grants, which include nonprofit entities, UC cooperative extensions, and RCDs, to name a few. As I mentioned, these grants focus more on research components and collecting GHG emission data for quantification methodology, and there's also an outreach component for these grants. And for the outreach, this requirement is on-farm and online field days that are mandatory throughout the grant term, and reaching out to at least 120 different farmers and ranchers through these events. During the life of the program, we've funded 71 of these demonstration projects with an estimated GHG benefit reduction of about 3,900 metric tons of CO2 equivalent, covering a total practice implementation acreage of a little over 3,000 acres, and having an outreach from the closed out projects to about 1,200 California farmers and ranchers discussing the practices implemented. To touch on our last type of grant, this is the one that's currently under development, as I mentioned, and this is our block grant pilot program. I've listed the eligible entities on the slide, which include nonprofit entities, UCs, CSUs, and RCDs. And these groups would work with what we're terming as the grant beneficiaries, or eligible entities for the incentive grants that we'd be doing these on-farm practices. So grantees for these grants would be working on behalf of CDFA to disperse funds to help implement these on-farm practices. We're currently accepting public comment for this last form of grant that we're developing, and we're accepting comments until the 15th, so that's in a couple of days. You can find the draft request for grant application on the main Healthy Soils webpage. And if you have any comments you'd like to submit for us to review, I've included the email address there on the slide. That is the main Healthy Soils program email address that we check. Moving on for future solicitations for the program, we're anticipating for this coming year that we'll start out first with our block pilot grant program in mid to early 2023. Our demonstration program, we're anticipating to release our solicitation in mid 2023, and then following with our incentives program in potentially late 2023. Thank you. And that was a brief overview of the program. Either I'll take questions now or after the other sponsor comments. Thank you.
Thank you very much, Elizabeth. I don't see questions. Yeah, I don't see questions in the QA. So we will move on to our next speaker. For the audience, if you have questions, please type your questions in the QA. We'll have those answered as we go. Well, thank you, Elizabeth, again, and thanks for your support for our project. Our next speaker our next speaker is Denise Molinex, and she is speaking on behalf of our one of the sponsors for this research is the California Dairy Research Foundation. And Denise is executive director for California Dairy Research Foundation. And she also serves as assistant director of the California Dairy Quality Assurance Program. And she has many years of experience in leading on-farm change, has worked in both academia and the private sectors worked very closely with the dairy industry. And as again, also Denise has been working with us very closely on this research for the Healthy Soil Project. Denise, please. Denise, can you unmute yourself?
My apologies, rookie maneuver. Good morning, everyone. I'm very pleased to be here and I really appreciate the kind introduction. As Dr. Zhang mentioned, my name is Denise Molinex, and I'm the executive director for the California Dairy Research Foundation. A little bit of background on the California Dairy Research Foundation, or CDRF. We were created by the dairy industry to fund and research scientific education programs to really support a sustainable and innovative California dairy industry. We fund research and scientific education programs in 5 key areas, those being environmental management, human health and nutrition, social responsibility, capability building, and product innovation. We are primarily funded by dairy producer dollars through the California Milk Advisory Board, but we also seek to leverage our funding to the greatest extent possible, specifically by co-funding projects. So projects like this one that we're going to be speaking about today. We're very pleased to be part of this project, looking at the production of products from dairy manure and almond woody biomass. We're very interested in supporting the development of products specifically from dairy manure, really as we see them as win-win products, obviously providing very useful soil amendment / fertilizer products at a very reasonable cost for our fellow ag producers, while really enabling the dairy industry to increase their exports of manure off farm and improving their whole farm nutrient balance. So this project is especially interesting because it is partnering with CDFA and the almond industry, and will also benefit the almond industry in utilizing its woody biomass. And also developing these pellet products, which we see as very useful products. They're very transportable, easy to apply, and hopefully will fit very well for other ag users in the utilization of these products. And finally, we also are interested in documenting the benefits of these products, so all of us can take advantage of that. We're really excited that the team is now at the point, they've been researching for several years now, and they're now at the point where they're going to be presenting final results and findings out to stakeholders. And we really look forward to stakeholders and taking this information and putting it into practice in their own facilities, in their own processes. So with that, I'll hand it over to Dr. Zhang and the next speaker. Thank you for having us.
Thank you very much, Denise. Okay, we'll move on to our next speaker, Guangwei Huang. Okay, we'd like to introduce our next speaker, Guangwei Huang. Guangwei is going to speak on behalf of Almond Board of California, and Guangwei is Associate Director of Food Research and Technology for Almond Board of California, and he manages directs research in almond quality, safety, and processing technology, co-product utilization, harvesting technology, and other programs. And he conducts trade education events and the food professional outreach activities. Guangwei has been a very strong supporter of our research. Thank you, Guangwei. And we'll stop share. I'll have you to speak.
Okay. Thank you, Dr. Zhang, for your introduction and invitation to make a few remarks. Good morning. This is Guangwei Huang from Almond Board of California. I joined Almond Board in 2001 and started to oversee our research in the food safety, established a mandatory pasteurization program, and start research in almond quality, and almond applications. Recently, we start our research in the biomass upcycling exploration. So first of all, I probably, instead of introduce about our industry, I probably want to, please allow me to offer our gratitude and congratulations to you and then the research team for completing the project during COVID. Almond Board California is very pleased to be part of this project, co-funding additional research with California Dairy Research Foundation to this multiple year CDFA Health Soil Project. And Almond Board is just the trade organization representing all like 7,600 growers and over 100 processors. There is the holler between 100 growers that they are not our member, but they indirectly involved because they're either growers or handlers. So they are one accumulated the one of several biomass, the whole shell and the sticks used in this project. So the team made a compost product from almond woody biomass with dairy manure, utilizing woody material as a carrier to retain minerals and nutrients from manure. Then apply the compost to the almond orchards as a soil amendment. This really created a solution to deal with bio-agri waste for local laboring dairy and then almond farmers. The project used the almond sticks as a woody carrier. The sticks are the biomass generated from harvesting, then accumulated at the hauling shelling facilities. The sticks roughly account for 2% of a fuel run weight, varying with the orchard ages and pruning practices. At 100 pounds of fuel run will produce 25 pounds of kernels. So the ratio of a stick is about 8% of a kernel weight. From the 2.6 billion pounds of almond production as a projected for this crop year, the industry will have over 100,000 tons of sticks accumulated at the various holler sites. So the project used and focus on almond sticks as offers some great solution. So there's not many options for disposal of sticks, as the open burning has been banned. Finding a good economical, sustainable outlet is critical and urgent for the industry. This project has identified an ecological way to make fertilizer from waste produced from local farms, and the outcomes have demonstrated potential value that can be generated from the biomass or bio waste. Besides the sticks, I want to try to extrapolate a little bit. Besides the sticks, the almond industry also generates other woody biomass, including old tree removals from replanting orchards and prunings from and attrition trees from the producing orchards, and the shells from the hauling shelling process. So our industry needs more outlets to handle all this type of woody biomass. Industry relies on whole orchard recycling and feedstock to cogen plant to deal with the tree removals. And thanks to the CDFA as one of the agencies, offer an incentive for whole orchard recycling. So that really help us dealing with those big chunk of woody biomass generated by industry. So that we need more alternatives ways to handle prunings, attrition trees, because the open burning been banned. So I can see how the outcome of this project with the sticks can be applicable, extended to handle prunings and dead trees. So we are, estimate there's a 1 to 2 tree, due to disease or wind blowing, probably each year, one tree, that's 1 or 2 tree gonna, account for about over, half ton of weight. And then prunings probably generate over 0.6 tons of woody material each orchard. Assuming every 3 years, the orchard gonna do pruning. So there's generate lots of woody material. In total, I estimate we probably have over 700,000 tons of woody material. Those going to be accumulated in the orchards. So really, if how we can put the effort to extend, apply the research findings from this project with the sticks to dealing with those prunings and dead trees from on the orchard side would be great. Then, of course, the composting need to be at this, carried out at the orchard side, and then at a small scale, that to avoid in transportation from various orchards. So if any outreach material on small scale composting or woody material with dairy manure can be created, they can be a useful tool to engage with almond growers. Looking forward to the comprehensive report from the team on the funding from the project. Really pleased to know that the project is ramped up. We should have a good results to do some outreach activity with our members. Thank you.
Thank you very much. Very well stated. And thank you, Denise and Guangwei, for introducing our project, Healthy Soil Project, very well, and also especially the feedstock we worked with. Okay, and so I'm going to move on. Again, if you have questions, you can type in the QA. Okay, so yeah, in this Healthy Soil Project, we have been working on the past 3 years, and our project is going to conclude in March of 2023. And so this is the workshop we wanted to share some key findings, and also the methods we used and the results and key findings from this project. And so Huangwei has mentioned about the woody biomass. So in this project, we worked with the sticks, twigs collected from almond processor. We also worked with the dairy manure, the solids separated from dairy, flushed the dairy manure. And so we collected and composted the dairy manure lung, and we composted the dairy manure mixture with the woody biomass sticks and twigs. And with the goal and for this research is to recycle dairy manure and this almond woody biomass in almond orchards as a nutrient-rich, safe, organic amendments with the expected many economic environmental benefits, including soil and the tree health, greenhouse gas reduction, and carbon sequestration. So we'll be reporting our research results findings with regarding to those impact and benefits. And the objectives of research in this project are three. The first one, and we worked with the dairy, commercial dairy, and also we worked with the commercial almond processors. So we collect this feedstock, we characterized, we measured, and then we did a compost. And we evaluated the compost alone, and also we used the technology to produce a pellets. So we pelletize the compost, the products. So we have two types of products, compost and pelletize the compost. And we investigated and demonstrated the effectiveness of these products, both the compost and pelletize the compost products. We applied in the commercial almond orchard and did a lot of research and measurements, data collection, and data analysis. And so now we'll be reporting those. And today, with the purpose to have this workshop, so we can share our research results with you. And this project involves many, many people. Besides our research sponsors, project grant managers, and so research team involves faculty, staff, graduate students, undergraduate students of UC Davis from several departments. And the principal investigators are listed on this slide. So I am the PI for the project, but I worked with my colleagues and from Department of Biological Engineering and Department of Plant Science and Department of Population Health and Reproduction, and also Department of Animal Science. So it's an interdisciplinary research team and who have worked really hard for past 3 years, overcome many challenges, especially during the pandemic period. And so some of our co-PIs are here, and they will be presenting the research as well. And Dr. Hamid El-Mashed, Dr. Sad Dangshan Kausa, and Dr. Pramad Pandey. So they will be presenting the research next. And also wanted to thank Professor Patrick Brown, Professor Frank Mitterluner for working with us very closely. And also there are many researchers, and including Hossein Dalati, PhD student you just met, and he has been the lead researcher for this project, and worked with Alan Cho, PhD student. He's running the Zoom today, and also Dr. Yika Chen, Dr. Tyler Barzi, and they are joining us here as well. And besides the research team, we have got a lot of support and also work with advice and on the ground working with us from 2 farms. And one's a dairy farm, the other is almond farm. And Aaron Wickstrom, and he is from Wickstrom Dairies. And Aaron has worked with us very closely on his dairy in terms of manure and woody biomass composting, pelletization. Aaron was originally planning to give his remarks and talk today, but he couldn't join us this morning. And so he sent his regards to our audience, to us. And also JD Van Ruler, he is the grower, almond grower, who very kindly provided his orchards for us to do research, do experiment in his orchard. And also many industry collaborators who provided the services, equipment to make our research activities happen. And I wanted to thank all of those people. And next, we will move to research presentations. So we have 4 featured research presentations. And so Hossein Idalati will be presenting composting, pelletization, and orchard application. And Dr. Pramod Pandey will be presenting microbial safety of dairy manure products, and also the products we produced and applied in the orchard. And Dr. Hamid Yel-Mashat will be presenting field greenhouse gas emissions and compost product economics. Dr. Saad Darshi Khalsa, and he will be presenting soil health and almond tree performance. Okay, with that, okay, so I wanted to introduce Hossein. Okay, Hossein is currently PhD student and planning to graduate very soon. And Hossein's research has been agricultural byproduct utilization, bioresource utilization. He has participated a lot of several projects. This is one of the projects under his wing. And Hossein, please.
Thank you for the introduction, Professor Strong. Yeah, so I will kick off the research presentations. And briefly, one of the main goals of this project was to take dairy manure and almond sticks and twigs and to produce biofertilizer products that could then be applied safely into almond orchards. So we'll look at how we go from manure solids and sticks and twigs, the raw materials, to compost and to pellets. And I just wanted to give a quick peek of a sneak peek of what these products look like. You'll see throughout the presentation references to MC, MSC, PMC, and PMSC. You can see what those abbreviations stand for. MC is manure compost, MSC is manure stick compost, PMC is the pelletized manure compost, and PMSC is the pelletized manure stick compost. So this table here gives you an idea of the composition. We'll talk about it a little bit more later. But aside from producing and applying these products, we did some field measurements. We looked at the physical chemical properties of the soil. We looked at pathogens. We tested the products themselves for pathogens. We looked at the soil. We looked at the almonds at harvest to see if there were any pathogens. We did some analysis of the tree and almond health, looking at tree circumference. We did some leaf analysis. We looked at almond yields, and again, pathogen analysis. And there's some experiments that we did that looked at emissions from the soil after application of these products. Again, the goal of this project was to recycle dairy manure and almond orchards as a nutrient-rich, safe organic matter amendment. while sequestering carbon and providing economical and sustainable benefits to the soil, crop, and environment. We investigated on-farm composting of dairy manure and dairy manure composted with almond sticks and twigs, and produced and characterized products, compost and pelletized compost products, and we characterized physical and chemical properties of these products. We then applied the loose and pelletized amendments using a conventional orchard applicator. We studied the effects of these amendments on the soil and the trees as it relates to carbon sequestration, soil properties, pathogens, greenhouse gas emissions, tree health, almond yield, consumer safety, and we conducted some economic analysis of the products. And finally, the last objective was to conduct outreach activities and disseminate the results to stakeholders at workshops like this. So this is probably not new information to many of you. The dairy industry represents the #1 commodity in the state in terms of agricultural output, with $6.4 billion in receipts. We account for 19% of the U.S. milk and cheese production. We're the #3 agricultural export. The dairy industry is 1.7 out of so 2.5 million cattle in the state are part of the dairy industry. 1.7 million of those cattle are milking cows. In terms of challenges, over the many decades, with reducing number of farms and increasing herd concentration, there's been an impact on our air and water quality. California is a tough regulatory and business environment for many dairies, and many dairies generate a lot of manure, more than they know what to do with. In terms of the almond industry, this project will focus on the orchard debris accumulation by processors. When we spoke with the almond board, they expressed the challenge that a lot of the field weight of what goes to processors, 13% of it is just orchard debris, which consists of dirt, pebbles, rocks, sticks, twigs, trash. The twigs and sticks can be dirty and difficult to dispose of, and they can accumulate and take space on the processor facilities for many years. In terms of the dairy industry, on a typical dairy in California has about a herd size of 1,250 cows. So that's about over a 6-fold increase in concentration since the 1980s. A typical dairy cow excretes 120 pounds of manure per day. That manure is equivalent to the California human population of waste that we generate. About 50% of the methane emissions in the state have been attributed to the dairy industry, and this manure can impact the air, the water, and so these are some of the challenges of the industry. The particular dairy that we worked with had an advanced solid liquid separation system, and the solids that we work with for this project were the separator solids, specifically the fine solids. This is a nice, clean source of material for composting. This particular farmer uses a lot of the coarse and fine solids for bedding. The farmer recycles them by advanced solar drying, which is akin to composting. They have pretty rigorous composting operations on the farm, although they are not a composter. And excess solids are actually applied to land that is not adjacent to the dairy. This farmer has about 350 acres adjacent to the dairy, and another 650 acres that's not adjacent to the dairy that can't be accessed from fertigation from the lagoon. Again, orchard debris is on average 13% of the fuel weight of material brought to processors. Debris is often not clean, consists of dirt, pebbles, rocks, sticks, and twigs, and trash such as drip tape. It has little to no value. It's given away at best. At worst, it can take up space for many years. It can be a fire hazard and can take money to process and to have hauled away. And this is just an example of one of the facilities that we visited. This is the processing line where some of the sticks and twigs are separated. You can see more sticks and twigs separated here at different unit operations down the line. And these are just some examples of sticks and twig piles that you might see on some processors. This processor in Chowchilla actually spent money to have their sticks and twigs ground. Although in our project, we ended up getting help from RDO and having them come out with a big hammer mill and have them grind the sticks and twigs even further for the purpose of composting. So what is composting? Composting is an aerobic biological process. It can produce fertilizer that is stable and free of pathogens and plant seeds and weeds. Composting is a nice process for reducing organic waste. It can help mitigate methane emissions because it's an aerobic process. And compost can improve soil health and helps conserve water. So in California, if you think about the relationship between almonds and dairies, there's already been a longstanding relationship. A lot of dairies already use hulls and shells for bedding, hulls for feed. And so what we thought is that maybe if you could take some of those sticks back to the dairy, do some composting on the farm, and then you can recycle those amendments back into the orchard. There's a lot of overlap geographically in terms of these two industries as well in the state. So in terms of the process that we were looking at in this project, we were taking dairy manure and sticks and twigs. We were composting them actively for 8 to 10 weeks using windrows that were turned once a week. That compost, after active composting, was cured for a couple months before it went to before we put it in through our pelletizer, and that produced our 4 different treatments that you can see: manure compost, manure stick compost, pelletized manure compost, and pelletized manure compost, which were then applied into our experimental plot. In terms of the experimental design, this was a randomized complete block design. There were 16 trees per microplot. The different treatments were unamended, dairy manure compost, pelletized dairy manure compost, and then there was dairy manure stick compost and pelletized dairy manure stick compost. The tree variety was Independence, and the application rate was 4 dry tons per acre. And so you can see kind of how the piles were constructed. This is wood that's been being put into the loader. Then it's spread out, and the farmer's constructing the windrows. And then weekly, these piles were turned, aerated, and mixed. We returned weekly to take measurements and samples. And basically what we did is we kind of looked at each of these piles and put in temperature probes at 4 different locations in each pile. We monitored temperature in the pile about halfway up to see how hot they were getting. We were monitoring ambient temperature, and we were also taking weekly measurements of the dimensions of the pile to kind of estimate, how much of this material is getting burned off during the composting, how much moisture are we losing. And so this is some pictures of what some of that work looked like. And in terms of results, very quickly, the piles got up to 60, 65, 70, even 75 degrees Celsius. And the yellow dots represent the ambient temperature. The gray and blue and black and orange dots represent the temperature in the piles themselves. As you can see, there's a drop every week, and that is basically when the piles were turned, we would take the temperature sensors out. The manure stick piles achieve hotter temperatures faster, but both of them achieve pretty high temperatures between 60 and 70 degrees Celsius. And then again in 2020, we saw similar results. The piles achieve temperatures of up to 70 degrees Celsius. In 2019, we actually added water at the beginning of the composting process, but the manure is pretty wet itself, so there's not really much of a need. So we didn't do that in 2020. As the piles start to lose moisture around week 5, then the temperature starts to drop. And this just shows in 2019 kind of the change. The moisture content drops from 77 to 40% in the manure only, and 71 to 45% in the manure stick piles. And we're losing about 36% in terms of total solids on a wet basis, and 62% in terms of organic volatile solids or organic matter on a wet basis. After composting, we ran the compost through a flat disc pelletizer and kind of some of the benefits of pelletizing are it increases bulk density, improves handling and storage. It can reduce dust generation, can be more attractive for higher value markets. So these are some pictures of the lab scale pellet mill that we used. It's a pelletizer. It's been for collection, screen. And these are the results, or this is the composition of the different products. So as you can see, pelletizing increases bulk density of the manure compost by about 2-fold, and the manure stick compost by about 1.5-fold. C to N ratio between the manure compost and the pelletized versions doesn't significantly change, but there is an increase in C to N ratio when you add sticks. And you can see the NPK of the manure compost, pelletized manure compost, and the manure stick, pelletized manure stick compost. So at the rate of 4 dry tons per acre, we were adding 100 pounds of nitrogen, 28 pounds of phosphorus, and 72 pounds of potassium for the manure compost and pelletized manure compost. And we're adding 84, 18, and 60 for the stick equivalents. This is what the pellets look like up close and in the applicator. And this is just the calibration test that we were doing, but you can see how the pellets flow out of the applicator. And these are some images of compost application on the left and pellet application on the right, and how they flow out and onto the berm. This farmer had micro sprinklers at the site. It wasn't drip, so there's a bit more wetting that happens on the amendments. And this is harvest data from 2020. We didn't, between the different treatments, we actually didn't see significant differences. And in 2021, these were the yield results. So this chart shows farmer's data for what he had in terms of harvest from, he didn't have treatment level data, he had plot level data, and we kind of were comparing that to what we were seeing in the orchard, which was pretty close in terms of the number. And so in terms of conclusions, for composting after 8 weeks of active composting, temperature profiles and mass changes were similar between the two types of compost, the manure only and manure stick compost. The total solids loss was 36%. In terms of volatile solids loss, it was 62% for both. The woody biomass, we noticed, doesn't fully break down after 8 weeks of active composting. You can still see visible particles after 8 weeks, while the manure only compost is more homogeneous. In terms of pelletization, we observed that even though we were expecting the compost would have to be between 10 and 15% for pelletization, less than 20% was too dry. It was plugging up the pellet mill die. 35% was too wet. The target range that we found worked best was 25 to 35% on the dairy. We think that the higher levels of sand in the manure to be the reason for the elevated moisture required for pelletization. The nice thing about having higher moisture for pelletization means that you don't need as much time for drying after composting to be able to pelletize. We did notice that manure compost, the uncomposted sticks and twigs were a bit harder on the pellet mill roller and die. So one thing that might need to be considered is separating out and screening out those larger particles and reintegrating them back into compost piles, or milling the compost prior to pelletization. In terms of application, the higher bulk density means that more pellets can be loaded into an applicator at a given time. And we were successfully able to apply both the compost and the pellets without issues in the orchard. We did not see differences in terms of yield in 2020 or 2021 between treatments. And just wanted to acknowledge our project sponsors, collaborators, and that covers it for my part of the presentation. Thank you.
Thank you very much, Hossein. We'll move to our next speaker, Dr. Pramod Pandey.
Thank you, Dr. Zhang.
Okay, do you want to bring out your slide?
Yes.
Okay, so we'll go ahead and introduce Dr. Pandey. Dr. Pandey is a co-PI on this project, and he's a faculty member of 3 departments. And the Department of Population Health, the Reproduction, and he's also with the Department of Land, Air, Water Resources, Department of Biological and Agricultural Engineering. And his research focus has been controlling microbial pollution in water, wastewater. And so he worked with us on microbial safety pathogen analysis of our dairy manure and woody biomass compost products.
Thank you, Dr. Zhang, for introducing me, and also I appreciate you involved me in this project to contribute in terms of evaluating the pathogen and microbial pathogen quality of the product, soil and almonds. A little bit introduction about myself. I don't know if you can, the slide is moving? I cannot see that slide is moving in the presentation.
Pramod, we do see slide. Can you make it into presentation mode? Yes.
Yes. And is it moving?
It's a small, it's a moving, but it's a small screen.
I don't know how to move the slides because I'm moving in my presentation mode, but it seems at your end, it is not moving.
It moves. So it does go to next slides. Just go ahead to present.
Yeah. Did it move?
Yes, it does.
Okay. So just a little bit introduction about the department I'm working. I'm working in a school of veterinary medicine in the Department of Population Health and Reproduction. My expertise is animal waste management, basically microbial safety of animal waste, water quality. So we have a very nice setup here. The hospitals can treat small animal as well as large animals. A very interdisciplinary department. People are working on water quality, compost, animal carcasses, and soil amendments. My research interest is basically on microbial contamination in animal waste. And animal waste could be animal carcasses, manure, poultry litter, wet manure, dry manure, or lagoons, or liquid solid separator system. Coming back to the project, my contribution to this project was basically testing pathogens in products, soil and almond samples. So first thing was to implement the preferred and suitable procedures for microbiological analysis of samples. We used 3 different methods for enumerating bacteria in samples. And also we used 2 different labs for the microbial analysis. Enormous amount of platings, work, and redoing was done in order to ensure the robustness of data. So these 2 labs are here. One lab is located at Department of Population Health and Reproduction, School of Veterinary Medicine, UC Davis, and this is Biosafety Level 2 lab. This lab is equipped and designed for clinical, diagnostic, teaching, and research. It works on agents which has a moderate risk, for example, E. coli 157, Salmonella, and Listeria monocytogenes. And the second lab we use is a Kansas State Veterinary Diagnostic Laboratory. That lab is well recognized all over the nation, and basically it works on diagnostic samples and fecal sample analysis. So we use 3 different methods. First method was FDA's BAM method, Bacteriological Analytical Manual, and that is for E. coli and Salmonella. That method uses a selective and differential culture medium for bacteria enumeration. The second method we used was the EPA-based method, membrane filtration, that is used for detecting and enumerating thermotolerant E. coli. And this has excellent performance for detecting the thermotolerant bacteria, and the agar we use is basically 15 to 20 times more expensive than normal agar. And third method was PCR-based detection that detects a Shiga toxin producing E. coli. And we have analyzed for samples for STX1, STX2, E. coli 157, 15, 45, 121. So basically many serogroups. Type of samples, so this is the graph already Hussain presented. So we have 3 different types of samples. Year 1 and 2, we have a product sample, and those products are manure compost, manure-stick compost, pelletized manure, and pelletized manure-stick compost. Soil samples we tested for year 1, year 2, and year 3. So there were 5 treatments, 4 replicates in 3 years. We have total 60 samples. And almond samples, 5 treatments, 4 replicates, and 2 years at harvest. So basically we have total 40 samples. As Hussain mentioned, this experiment was randomized complete block design, which is a standard type of design used in this kind of testing. So first I will present the results for the Salmonella. So we use XLD agar, which is a differential medium used for the isolation differentiation of Salmonella in food samples, environmental samples, in clinical setting. So once we dilute or mix pellets or soil sample with PBS buffer, then we do the plating. And if there are, after 24 hours, when we incubate the plates at 37 degrees Celsius, if there is a Salmonella, then we will be having red colonies with black centers. If those colonies exist, then we say that there is a Salmonella in the samples. So we use the same method for soil, product, and almond samples. And you can see in the bottom that these kind of plates we got after the incubation. None of these plates were with black center colonies. And this kind of led to the conclusion that these samples does not have a Salmonella, and which is very similar to the previous results. Many scientists, they try to detect the Salmonella in manure samples, especially dairy samples. And most of them, they concluded that Salmonella may not be a big issue in a dairy product because there's not much growth, there's not much Salmonella detection. Second was E. coli testing. These are the results for E. coli. So we use McConkey agar, which is a solid selective differential agar, and it cultivates gram-negative bacterial species. It is used for detection of E. coli 157, E. coli in environmental samples. So the same sample preparation method which we use for Salmonella, we use for E. coli as well, as mixed with PBS buffer and then plated 100 microliter in these plates that has agar, McConkey agar. And if there is E. coli, then it will give us pink to dark pink colonies like donut shaped. So we used the soil sample, product sample, and almond samples. What we saw in the plates, there was not like exact E. coli 157 or pathogenic, but there were mixed growth. And since it was a mixed growth and we were not able to confirm that they are E. coli or pathogens, we needed to do a secondary level of confirmation, and that was needed. So then we used a third lab that was Kansas State Veterinary Diagnostic Laboratory. And basically we sent all those samples which we saw the mixed kind of growth. And finally, these are the kind of reports. So none of those samples were positive to all the E. coli 36, 45, 157, SX1 and 2. So almost all samples were negative for those pathogenic organisms. So finally, conclusion is that we have tested these samples for E. coli and Salmonella. Testing was done, and the study is robust, reproducible. Secondary confirmation was done to verify E. coli 157 because we wanted to see if that growth is pathogenic or not. We use standard methods, FDA and EPA-based method. And based on these analytical work, we can conclude that samples were negative to Salmonella species, samples were negative to pathogenic E. coli in a species. Few growths which we saw in the beginning, that was mostly protease, and those are common in environmental samples. And if you want to get rid of those kind of growth, then certainly you need to do sterilization. And that is beyond the scope of this project. So I wish I could have more interesting results, but the thing is that we have not found any pathogenic organisms. So the interpretation is very simple, that the product we tested, it does not have any pathogenic microorganisms. And that is the end of my presentation. Thank you so much. If we want to see the further identification of those growth, then perhaps we have to do whole genome sequencing, and that was not the scope of this project. Thank you so much.
Thank you very much, Parmat. Appreciate your presentation. And next, we'll move to Dr. Hamid Yelmashet. Parmat, can you stop sharing?
Okay.
Okay, so we have Hamid's presentation up. Okay, great. So Dr. Hamid Yelmashet is a staff research associate in the Department of Biological and Agricultural Engineering. And so he's a research focusing on bioresource recovery, waste management, and wastewater treatment. He's an expert of funnel digestion, composting, and other waste or biomass conversion processes and technology. And so he will be presenting the field, the greenhouse gas emissions and product economics findings.
Thank you, Professor Zhang, for the introduction. Good morning, everyone. As Professor said that my name is Hamid Mishad, and actually I'm presenting this part on behalf of the research team here. It's not only my work, but actually this is a team effort. So I would like to go first in some introduction about the emissions from fields, and then I will go methodology used for emission measurements on the orchard, Almond orchard specifically for this project. And then I will present some of the results that we obtained through this measurement of the emissions. And also I will end up with preliminary cost analysis of pellet production. So if we look at here, this is carbon and nitrogen cycling in orchard agro ecosystem. We'll start actually from maybe applying some fertilizers. In our project today, we also applied some carbon. So basically fertilizer contains some carbon from the pellets and from manure products. And also we have nitrogen, of course, in the product. We have also some kind of nitrogen from the atmosphere also. This can be also as part of the ecosystem here. And we have also leaves, carbon nitrogen. These leaves can also drop on the soils, can be contributing to the carbon and the nitrogen balance. And of course, some of this carbon and the nitrogen can live with the carbon outside of the field, basically. We have here, if we have the material actually reaching the roots of plant here in orchard, there are some microorganisms and enzymes, all of this microbiota in the soil that can convert all of this carbon and the nitrogen to different gases. Among them, of course, some may be carbon dioxide, and here some may be also methane, but in reality, we have also found that, or researchers basically found that orchard can be oxidizer for methane. Beside actually this carbon cycle here, we have also some processes for nitrogen. There is some immobilization for in the soil. Of course, if we have some carbon that can be also immobilized in the soil, which is actually carbon sequestration in our case today. And also for nitrogen, also can have the organic nitrogen in the product can be mineralized to ammonia that can undergo nitrification and then reducing nitrate, and then the nitrification that can be reduced at the end is nitrogen. And of course, we have also some NOx and some nitrous oxide. So basically today, we are actually interested in measuring the emissions of nitrous oxide and also carbon dioxide as carbon emitted to the air. And what happened to methane? This is basically the three gases that we are discussing today for the GHG or greenhouse gas emission from the orchard. So what we did here, this is what we measured. So we have the orchard here. We have used the flux chamber, static chamber, and we have here the flux chamber added. One chamber was employed for each plot, for each treatment at the berm here, and between majority of the treatment between 5 and 6 trees. It might be actually moved from between 1 and 2 sometimes, but majority of them was between 5 and 6 trees as we numbered them. And also one of the flux chamber was also employed in the alleyway. So we have there, we also, this is basically the picture of the flux chamber and how it looks like. And here, this is how to measure the temperature in the head space of the flux chamber. And the last one, how we sampled actually the head space of the flux chamber. So before actually we collect the samples, we have to, we monitored actually that we need to measure prior and after the irrigation and the precipitation, basically 1 day before the event, either from irrigation or precipitation. And after the event of water applying to the field, we measured also 1 to 4 days after the event. We started the emission measurement at 2 o'clock in the afternoon, and then sample over 1 hour period in the head space of the chamber as recommended by the standard method for this analysis. Temperature also was measured for the temperature for the soil and for the headspace of the flux chamber, and we sampled the soil on the day of measurement of the emission. What we measured methane, nitrous oxide, and carbon dioxide using the gas chromatography. So what we measured here, we have 5 events. We measured actually in July 2020, May 2021, July 2021, October 2021, and March 2022. We have 3 events of irrigation and 2 events of precipitation. This is the days that we measured the emission, again, 1 day before the event of water application, and at least 1 day after the event. So here, this is, I would like actually just to present a few of these events. And here, as you can see, this is the emission of methane, nitrous oxide, and carbon dioxide in May 2021. As you can see here, that we have some flow chart here. The top one is the relation of nitrous oxide on the day before irrigation and the day after irrigation. The second chart is give the methane also day before irrigation and the day after irrigation. And the lower one is carbon dioxide, the same period of time. On the right-hand side, you can find also the total mineral nitrogen on the day before and after the event. And the second chart is the soluble organic carbon on the same thing, also same time. And the last one is the temperature of the headspace during the measurement of the gases. So I would like actually to generalize actually what I'm saying about the temperature. Temperature basically didn't change over time during the measurements. Actually, if you look at each day of the measurements here. And back to this nitrous oxide, if you look at this chart here in the top left, you will find actually that pre-irrigation here, there is no emission. There was very little amount of emission. However, after the emission, there was some emission of nitrous oxide, and there was some significant difference maybe between the alleyway and the manure compost and the manure sticks, which is good. This means that there is no emission from this treatment in terms of nitrous oxide. The other treatment also, there were actually some emissions, but there were no significant. For methane, there is actually majority of the treatment here were actually sinking methane. So basically the flux was negative, which is also complying with what literature said, more or less. Maybe a few actually, or a small amount of emission for the alleyway here, but generally we can say there is no positive flux of methane emission here. Again, here, this is, if we look at pre and post irrigation, we can find that irrigation actually increased the emission of nitrous oxide and carbon dioxide as well. So again, this may be also the same thing, also the same trend is here, maybe more or less. The same chart also are arranged similar to what I just said in the previous slide. And here, this is the pre-irrigation, no significant differences in the emission of nitrous oxide and carbon dioxide were determined here and here also. There is no significant, or actually the emission was really low. And also post irrigation, there was no significant difference in the emission of nitrous oxide between the treatment and the control, which is good thing also. Even after 1 day or even after 4 days, there was little actually differences there. A higher emission of nitrous oxide was also determined after the irrigation, especially for carbon dioxide here in the lower chart. And here, maybe actually if you compare between each treatment here, there is, yes, similar or even a little bit higher for nitrous oxide. Again, for methane, the same story is that there were not actually methane sinks there. For the March 2022, the same thing actually here, also the same arrangement for the chart that we have also nitrous oxide on the left here. And the most interesting part here is that most of the treatment had net nitrous oxide sink, which is interesting actually to note, except maybe the pelletized manure compost. There was some positive here, but generally we can say that most of the treatment had net nitrous oxide. This is actually can happen. This has been reported in the literature, especially if we have lower mineral nitrogen. So basically, if we look at this chart on the right-hand side here, we have this may be one of the lowest mineral nitrogen that we measured among all the events that we monitored there. So basically, this may be the reason, or also it can be also because of the higher moisture content of the soils. Again, this also it's actually complying with the literature under this kind of condition, but it's still actually interesting actually to have more actually data to confirm this if, for future research. The treatment also for methane, the same trend that the treatment and the control were not where net methane sinks, means that there is no positive actually emission of methane for all treatment and from the alleyway and the control. Again, this is also the same conclusion for emission for pre and post precipitation. No significant difference in the emission for carbon dioxide. Probably also again it can do with the precipitation event. The next part that I'm going to present today is the cost analysis of the pellet production. Here this is just very preliminary actually data that we calculated, and here this before actually going to the economic part. This is on the right hand side here you can find the hammer mills. This is CME, this Colorado company that sells this kind of hammer mills, and this also the same companies sell the pellet mills. These systems actually, we have another project for the dairy that we are working with, and they put actually this as pilot scale system, and this actually system we used as input for our model today. Again, this is the in this bucket, and this in hand here, this is the pellets that we hope this project actually will produce similar pellets that we produced in the pilot scale for this project that presented by Hussein in the beginning of this presentation. So what we did for cost analysis, we have capital costs, including the equipment, the building, and the installation cost. And based on the capital cost, we calculated the annualized capital cost, how much money is actually attributed to the capital cost every year. And we did also the operational cost, that including the labor, electricity, and the maintenance. And again, this is just we used for the labor, we used actually the common labor rate, and we also calculated how many hours per day and so on and so forth. And for the electricity, we got actually the blade rate for this equipment, and maintenance also we have assumption for this for the maintenance cost. Again, for the daily operation time, this we assume actually that this system can go for a small farm or maybe for large farm like what we have in the other projects that both actually this system means that the system can work for 24 hours. So again, here this is the input for the cost analysis. We have the interest rate for 8% every year, and we have the capital cost about 255. This is actually including the building, including the equipment, including the installation. And this is based on that we have the annualized capital cost about 29,000 or about 30,000 per year, and the number of working days 260 days per year. And the capacity of this system is 1.1 ton per day, per hour. So in this case, again, we actually assume that what would be the cost for a small farm that can only run the system for 8 hours. And here, this is the cost per ton here. Basically, the operational cost is a total yearly cost, and pellet production basically about 2,364 ton per year. And at this capacity, we can actually calculate the cost per ton about $41. If we actually have bigger farms, this may be actually drop to about $33 per ton. Okay. So with that, actually, I would like to conclude here. Again, this is a higher emission of carbon dioxide and the nitrous oxide were determined post-irrigation than pre-irrigation. For most of the emission measurements, there was no significant emission of nitrous oxide from amended and unamended field, and negative methane flux was determined for all treatment and control. Of course, we need actually this basically was just event measurements after irrigation or precipitation, but we need actually to have longer term and more frequent emission measurements so that we can actually have a better calculation for the carbon and the nitrogen budget. Again, as the last conclusion here, this is the estimated cost. Again, this is preliminary, maybe actually change in the future, and this is what we hope actually after the farm installs the big system. We are going actually to measure the real electricity there and see how this system will behave and how the pellets that will be produced from this pilot scale will be different from that is produced from the small scale that we used in this experiment. With that, I would like actually to end up here and thank you for your attention.
Thank you very much, Hamid. You answered one of the questions that was posted about the cost of pallets. And certainly besides pallets, there was a composting, manure collection cost, which we are adding. We're still in the process of doing cost benefit analysis, and we'll have those results included in the final report. Thank you, Hamid. Okay, so our next speaker is Dr. Sat Danshan Khalsa, and he's on the faculty of Department of Plant Science, and he is an assistant professional researcher. And Dr. Khalsa's research focusing on nutrient cycling management in tree crops, integrating plant, soil, social sciences. And in addition to leading multiple research projects efforts in the soil crop, especially orchard research. And so he is also project leader on a statewide effort to training certified crop advisors in the specialization of nitrogen management. He will be presenting soil health and almond tree performance research data and findings. Sad, please.
Thank you, Dr. Zong. Happy to be here with everyone. Just a thumbs up to everyone. You can see my slides and hear me okay? Very good. Awesome. So I'll speak today about soil health and almond tree performance as related to this Healthy Soils project that we all heard about so far this morning. So again, my name is Sat Darshan Khalsa. I'm in the Department of Plant Sciences at UC Davis. And I'm really excited to be talking to you all today about this particular project. I think it was kind of the culmination of a lot of different efforts. Started when I was a postdoc quite a number of years ago, in seeing that the dairy industry actually had a lot of synergy with the almond industry, and trying to see how we could bring these two industries together to solve important problems. The dairy industry had a resource in manure, and the almond industry had needs in terms of nutrients and soil organic matter, and seeing how we could bring them together. And I think all the speakers that have presented so far today have shown that indeed that this can be possible, and high quality, safe, valuable manure products can be made by California dairies and applied to orchards. So in my presentation, I'll go through a little bit about the grower analysis that I did before the start of this project, talking about those grower concerns. Those are almond growers, and sort of the overall availability of organic matter in the San Joaquin Valley in particular. I'll talk about soil health, not the entirety of soil health because it's a very complex and exciting topic, but I'll talk specifically about nutrient and salts, which have always been a concern when using manure products. So I wanted to make sure we have data on this project related to that, and I wanted to deliver some of those results for you all today, as well as how it relates to organic matter. And in terms of tree performance, like my colleague had just said, we didn't see any negative impact on using these products in orchards. At the same time, we didn't necessarily see an increase in yield quite yet. That was highly significant. But there are certainly other valuable uses for using manure products and other types of compost and amendments in orchards. But today I'll just touch a little bit on what we found as related to macro and micronutrients. And then lastly, one of the themes that came up from this particular research project was the effects on soil texture. Effects, it should say, of soil texture. So we had a previous study that looked at some of these similar measurements on different soil types. This study was ongoing before we actually even selected the site. And some of the results we see here actually matched with what we found in that published research paper. So there's some sort of opportunities to examine our work at a wider scale. But I'll start by talking about briefly about the concept of barriers to adoption. Typically, if there's a really great idea or a great opportunity in agriculture, there are certain barriers that need to be overcome beyond just the technical barriers of what to apply, how much to apply, et cetera, but really trying to understand the user, in this case, the almond grower, in terms of what they perceive as concerns with a new practice. So we asked this particular question back in 2015 and published in this paper, myself and Dr. Brown. And what we found when we asked almond growers about using different types of amendments like manure, that food safety was the #1 priority. That makes a lot of sense, as almonds are, though there are kill steps for pathogens and pasteurization and that kind of thing, the idea that an almond grower's yield would be rejected by someone and they wouldn't get paid because of finding a pathogen was a real concern and fear. And thus understanding that barrier was really important. I think my colleagues who have presented already really showed that actually we can produce a food safe, quality manure product. And we addressed that priority most comprehensively in this project out of any other projects that I've worked with. So I think that gives, in my view, should give confidence to the almond industry that there are safe products that can be made by the California dairy industry or partnerships with the California dairy industry. After food safety, though, if we dug a little deeper, we saw that people who did not use amendments were more concerned about cost than people who did use amendments. And people who did use amendments in our survey, which was the comparison of in this figure of users and non-users, we're more concerned about nutrients, how the nutrients are available. So that's kind of what we'll dig in a little bit more in terms of nutrients today in my talk. In the same study, we actually asked about accessibility. Often we find that the costs of many amendments are typically related to transport, believe it or not. And probably many people on this workshop are aware of that. Often you can get good quality amendments, but the biggest cost you're going to pay is in transporting them to your farm. So we asked the question about accessibility, and we found that obviously this project has shown that manure, like we did in this study, showed that manure is a huge opportunity, not only because it's accessible, because it's abundant, in particular in the San Joaquin Valley. So this was sort of a real eye-opener to say, this material is here, it's accessible, and what we did is follow it up with this work to show that it can be made food safe, in a food safe way, and in quality way. So thus the partnership with the dairy industry and the almond industry with this project. So I want to dig into some of the results that we found for this particular work. The first is around soil health. We saw elevated cation exchange capacity after 2 years, and that's the figure that you see there on the top. So from when we applied after 1 year, there were kind of no big differences, as you can see here. But after the second year, we start to see some increases in the different treatments that you've heard about already compared to an unamended control. There was no significance just yet, but the fact that we start to see this after 2 years is a good sign, and we saw something similar. Keep in mind that the soil that we're on is a very, very sandy soil. And indeed, this research supports other research that sandy soils are actually going to take longer to change their soil properties when amended compared to a more loamy soil. That makes a lot of sense because often organic matter kind of needs to associate with other finer particles and textures within soil in order to sort of see a change in soil physical and chemical properties. While sandier soils don't have as much easy association between organic matter because there's lower amounts of clays and silts, and thus it's going to take more time. So this is a kind of counter to typical industry belief that amendments would do best on sandy soils. They can, and they do, but they're actually going to take more time to see change than a loamy soil. And that's kind of one of the things that we found in this study here. There were slight increases in electrical conductivity within the soil compared to the unamended control. And that makes sense. Some of the manures do have salts in them, and we need to be sort of aware of that. But you can't disassociate sodium from potassium very easily. So on one hand, we don't want a lot of sodium in the soil and then in the tree because that creates salinity problems. But on the other hand, almonds use more potassium than they do nitrogen, and potassium can be more costly. So the fact that potassium is being delivered as a valuable nutrient from dairies to almond orchards is a really important opportunity that we need to see. So we did see elevated levels of electroconductivity in the soil, not significant, but we also saw increases in soil exchangeable potassium, which is important, although those differences also were not significant. This is just a typical pattern, another picture that I've had to show the very clear application of manure on top of the soil, and really keeping in mind that we have zones within orchards where we can do different soil health practices. So while we want to get the most value from our compost by applying on the berm, that does open up the alleyway to do other types of practices like planting cover crops, for example. But also what we saw in these sandy soils is we saw increases in total carbon over both the years and total nitrogen, as we would expect, compared to the unamended control. However, again, these differences were not significantly different. And that might be attributed, again, to the soil texture. It's just going to take more time in a very sandy soil to see increases in soil health, as indicated by nutrient capacity, cation exchange capacity, and levels of soil organic matter measured in total carbon and total nitrogen compared to our more loamy soil. So that's a real take-home message that people need to be aware of from this workshop, is that if indeed you're going to make an investment in using manure products on your orchard, that if you're in a very sandy soil, you're going to have to expect quite a few number of years before you're going to see significant differences compared to a loamy soil like a sandy loam or even a silt loam soil. And those soils, you can see buildups and changes in soil health faster as related to physical and chemical properties. When we look at tree performance, again, I'm going to be talking mainly about nutrients. When we looked at the macronutrients of nitrogen, phosphorus, and potassium, we did not see any change compared to the unamended control. That said, all of these trees also received the same amount of fertilizers, and our treatments were on top of the fertility program already in place. So basically, that's suggesting that if there were any differences between the application of NPK nutrients in the manure products, that they weren't significantly different to overcome the fertility program that was being applied to the unamended control. That's a short way of saying that we did not see an effect on the way that we coupled the amendments with a full fertility program. However, we have other trials in other parts of the state funded differently where we have been able to reduce the nitrogen and potassium inputs by up to 15 to 20% after 3 to 5 years of amendments. And then we saw that there was really no effect on yield or leaf tissue levels. So in other words, as we use organic matter to build up soil health, we can potentially then reduce the amount of fertility that we apply, your UAN 32, CAN 17s, KTS, SOP potassium rates, and sort of start leveraging the nutrition from the amendments to sort of play that role or substitute that partially substitute that role of fertilizers. But in our study over the first 2 years, we did not see an effect, which essentially shows that it didn't harm, but it didn't necessarily help beyond the fertility that was already in place. In other words, the unamended trees had decent fertility and we were just applying more on top of it, and that didn't show an effect just yet. We did, however, increasingly find that there was a slight increase in iron and zinc. So over here on the top, we see the zinc levels in year 1, year 2 compared to the unamended control. Not significantly different, but being able to see an increase in iron is very interesting to see. And typically in zinc as well. So between year 1 and year 2 with our different treatments, we saw elevated levels of leaf zinc content. So that was good to see, because often micronutrient deficiencies can come at a large cost with foliar application. But seeing that the amendments are sort of creating some more availability using iron and zinc was encouraging to see. There was a variability effect in sodium. So we always want to think back to our concern about salts from manure products in orchards. In year 1, we did not actually see any effect. In fact, the manure treatments were a little lower than the unamended control. And then when we re-amended in year 2, we started to see that we're slightly higher than the unamended control. So that's kind of just showing that there's some trade-offs there. It's not to say that this data is showing that it's not creating a significant effect, but indeed, if I were to start using manure products in an orchard that I was operating, I would try to keep an eye on these sodium levels within the leaf tissue to make sure that it's not getting elevated, that could create a salinity risk and potential impact yield in the future. But our results show that that was not the case after 2 years. And of course, as we showed already, there was no effect on almond yield. So indeed, by using these materials, we are not showing that the almond yield was hurt in any way, but we would often say that in a lot of our work that it sort of takes some time in any of these work to sort of build up the soil. It's like making an investment to then start to see the effect on the tree. So lastly, I want to show some effects on soil of soil texture here. So this was a study that we did in Stanislaus County. We compared a loam soil with a very sandy soil. And when we increased both of those soils where we compared manure, wood compost, which was very similar to our manure stick compost, with green waste compost, both of those were able to increase soil organic carbon. So from a baseline, this is the pre-treatment, to after 2 years of application, we were able to increase here and here. The effect was larger in the loam soil than in the sandy soil. Still significant with the sand. It took 2 years, but compared to the loam soil had a larger effect going on here. So that again is just another data point to support that if you're going to make an investment in these types of products in your orchard and you want to see a return on that investment, effects faster, I would recommend targeting maybe a more loamy soil that you might have to see that effect. But if you're really trying to improve soil properties in a very sandy soil, you have to keep in mind that that effect is going to take longer to build up to anything as equal as your loamy soil, but still something that can happen. The same type of effect was actually saw with the cation exchange capacity for the loam soil, but there was really no effect with the sandy soil. And that's what we found in this study. In our study that we just saw, we saw a slight increase with the cation exchange with the sand, but it's kind of comparable results here. So in the loamy soil, we could see that the application of amendments increased the cation exchange capacity significantly, but in the sandy soil, there was very, very little to almost no change over time. So really keeping in mind that soil texture can play in a role in this sort of short-term efficacy of applying amendments in orchards. And when I say short-term, I'm talking about 1 to 2 years. So our summary that I wanted to, for today is simple in that the barriers to adoption really are depending on understanding more of this question around nutrient availability and some of the variability within our organic matter sources. When it came to soil health for manure, we see some signs of improvement with this very sandy soil. But like I said, it's really difficult to uncouple the good from the bad when we're using manure, right? And good, I would say, is potassium. The bad would be sodium. Both of them are monovalent ions. Separating them within a manure stream would be very technically difficult to do. So we sort of need to accept that if we want the good from the manure, which is the nutrients like potassium, the organic matter, that might be coming along with things that we need to keep an eye on when it comes to managing our orchards, like sodium and salinity. When it comes to obviously other issues like pathogens and weed seeds, those are things that we were able to take care of with the composting process. But when it comes to some salts, something to keep an eye on, but certainly not a game changer if you're thinking about using these types of materials. When it came to overall tree performance, we saw no effect on NPK, but keep in mind that our unamended trees were fully fertilized. So there could be an opportunity in the future to reduce the fertility overall in a treatment and then see how the manure products over time sort of can supply some of these important macronutrients. But we did see an initial smaller impact, though not significant, with some of our micronutrients. So it's important to say that when it comes to using manure products, that we can have a sort of effect across all the different spectrum of micro and macronutrients of plant nutrition. And lastly, the effects of soil texture are still evident here. Like I've shown in a previous study, that we see faster effects on loamy soils. But if you're going to try to employ and make an investment on your orchard on a very sandy soil, just keep in mind that it's probably going to take more time in order to see that effect. So just a quick acknowledgement slides for all of our different funders, not only for this project, but for other projects that have supported this work of soil health in tree crops. So thank you all. Look forward to the question and answer session.
Okay, thank you so much, Sat. Okay, let me share screen. We have been doing very well with regards to Q&A. Thank you for those of you who posted questions, and myself and our panelists have been doing a great job replying, answering those questions. But we do have several new questions, and we will answer those in our QA session. But before we go into QA, I would like to ask you to do a favor, and we wanted to ask you to do a survey again, second survey. After you hear the presentations and the remarks, would you please complete our second survey? Or have Hossein to speak to us.
Hello, everyone. Yeah, for the post survey, similar to the pre-survey, you could use your smartphone, just take a picture of that QR code to access it, or use the link, which I also put in the chat. There are some farmer specific questions, and if you're not a farmer, you can just mark not applicable for those. But it's just a quick 3 to 5 questions again. Thank you.
Great, thank you. We'll give you a few seconds to complete this short survey. We'll keep this on in case you need it to scan the QR code. Okay. I think we're doing very well with our schedule. And so to sum up, and we are almost completing our Healthy Soil project. We have but 3-4 months to go, and we expect and plan to write up a comprehensive final research report for this project. We'll be more than happy to share that report with you. And also, we are planning to do an in-person field day, sometime either in February or early March. And so we will let you know when we hold our field day for our Healthy Soil project. And again, wanted to thank our research sponsors, California Department of Food and Agriculture, Board of California, California Dairy Research Foundation for Healthy Soil project. And also wanted to thank again all our research collaborators, supporters, service providers who have worked with us in the last 3 years. And also on behalf of the research team, and wanted to thank you all, and also wanted to thank all the presenters for today's workshop. And if you do have questions and comments after the workshop, please send those to me. Okay, with that, I will do the QA. I will stop sharing. We have all the panelists, speakers here in the room. And there are, let me see, we have, oops, we got questions answered. So if you wanted to post more questions, or if you have your questions not answered fully, and if you can post the questions again, then we have our speakers, panelists here. I don't see any open questions.
I think we answered most of them by typing.
Right.
Do attendees, can they turn on their microphones, or is it only through chat questions?
If attendees raise their hand, we could make it so that they can ask a question live.
So that's on the reaction. Oh, so click reactions and then click raise hand, and then
Yeah. So if
Got
someone wants to raise their hand, then we could allow them to talk and ask a question.
all right.
Wonderful. And is there anyone in the audience who wants to speak or for your thoughts? And then you can raise your hand, and then Hossein can allow you to give you a chance to speak live. Oh, JP, thank you.
Hi, and thanks for answering my questions about where the emissions work was done. I noticed, I'm understanding that the emissions work was really not done on the composting part itself, just on the application to soils, and also that when the emissions were measured, they were greenhouse gas emissions like nitrous oxide, carbon dioxide, and methane, which is all valuable information. Composting is difficult to permit outside of a research setting right now in California. And while there is some information out there, better science-based emission factors are needed for manure composting. So I think there's some potentially a missed opportunity here, in the sense that we could have potentially measured composting emissions during the composting process for ammonia, which is a commonly a concern in air pollution and also in environmental justice discussions around dairies, as well as volatile organic compounds that are non-methane compounds, which are considered in emission factors that are used to develop permitting schemes. So if we're going to the trouble of putting together a compost in a research setting, I think it would be really wise to measure those emissions during that, to to support development and validation of science-based emission factors. And particularly when we're having novel mixes of compost, such as adding something that hasn't been in there before, such as twigs and sticks, that sort of thing. Because twigs and sticks may actually be mitigating emissions from the manure, or you know, it would be good for us to know if the emissions change upwards or downwards when different things are mixed with manure. So I just thought I'd make that comment. It's not intended as a criticism. It's just an opportunity if we go forward and are able to do more research like this, which is, I've really enjoyed listening to all this today, and feel like it's really important step forward in our knowledge about this stuff. I hope we can consider having that type of thinking about the air pollution side of this, not just the greenhouse gases side. Thank you.
So there are a number of researchers from Berkeley that have done measurements on compost pile. I can put some links to their work in the chat for you. Not to say that it's comprehensive or complete, but there is other work done on that.
Thank you, JP, and I agree. And getting data from, about the other emissions, including ammonia emissions, will be great. However, this project is a healthy soil project focused on the greenhouse gas emission measurement. That's with the limited funding. That's why we were not able to measure the emissions of ammonia, VOCs. However, we did measure ammonia in the soil. We also measured ammonia in the compost. But we were not, we don't have funding, or it's not in the scope of work for us to measure emissions. I totally agree. It would be great if we can collect data if funding allows.
There's another, Dr. Steve Kafka wanted to make a comment or a question.
Everybody, can you hear me?
Yes.
Okay, I want to say this is very important work. Our group has just recently done an analysis of nitrogen, particularly nitrogen surpluses on dairy farms and priority 1 nitrogen management zones in the San Joaquin Valley. And a good deal of those nitrogen, it's important because nitrate pollution of groundwater is regulated under CB salts and is recognized as an important problem in California agriculture. Dairies typically are thought of to have largely liquid manure and nitrogen liquid manure forms, but there are dairies that have a significant surplus, at least by calculation basis, as solid manure. And so any work that you can do, and this work contributes to finding ways to use solid manure nitrogen and phosphorus surpluses. And so anything that can be done to find ways to make solid manure more usable on non-dairy systems, and or including creating products that reduce transportation costs in particular, which, as you've mentioned, are significant, perhaps more significant than the cost of materials from a greenhouse gas perspective, is really important. So I want to, say congratulations on working on the solid manure fraction, and I would hope that there could be continued work in that area, because it's it is in fact a significant issue in the San Joaquin Valley.
Thank you very much, Steve. Appreciate your comments and the thoughts. And we still have a couple minutes. There are 3 questions in the Q&A. We'd like to have those answered. And so the first question is for Hamid. And can we use the same method of emission measurement for composting piles? So this question is about the methods of emission measurement.
Yeah, I think there are other methods actually. Maybe the emissions here are more small. Maybe actually you have to have a bigger actually flux chambers basically for the compost, because basically this is just static chambers. This means actually this is very small and there is no actually airflow through it. So basically in the composting, you may need actually to have a bigger actually flux chamber because you have aerations there, more or less. At least it's during the this kind of turning, you may actually have some kind of air going actually penetrates the bile. I don't think actually this can be suitable, but maybe bigger actually chamber they are used, but not just the small ones that we used in this experiment.
Yeah, in the paper that's in the chat, they used 2-foot diameter. I'm getting that right. Yeah, 2-foot diameter by 1 foot high. So it's quite a large chamber, but this similar methodology of a static closed chamber, but probably bigger, as I was saying. Yeah.
Okay, thank you.
Yeah, in the publication that you can see that it says it in their description.
Okay, thank you. Well, move to second. It's not question, probably it's more about it's a comment. This one is directly to Sat, and Sat can read. I can read it too. One important point brought up by Sat is the reduction of chemical fertilizers in the orchard. Concerns to increase salinity from manure compost, improvements on soil texture, water retention. These points will likely determine the farmer's adoption of the use of compost. Do you have any comments, further comments to share, Sat?
Yeah, I mean, it's using compost is going to have an additive co-benefit approach, right? It's going to help with the fertilizers, water retention, building soil organic matter, those types of things. So I think it's reasonable to think that it's not going to be one thing. I'm using compost for this. It's going to be a whole host of different things that will likely determine if the farmer adopts it. But when we talk about adoption, what the main barrier was for the almond industry was food safety. I mean, it was #1. And I think I have to, self-congratulate ourselves here to say that we really got that with the dairy industry. It was so critical. It's right. The manure's there. The orchards are here. What is the biggest barrier? It was actually around food safety. And we were able to demonstrate that actually, yeah, you can make a quality product here in California and move it mile or so down the road for use. And I think that's really the biggest outcome of this work, is to show that we can actually do that.
Very well said. Thank you. And okay. I was looking at one question from Nick. It's answered. So, okay. And then there's another one, and Sat. So this question is for you as well. Since the trees in your study were already fertilized, were there any studies done on the impacts of water to water quality from additional application in those sandy soils that can take many years to see benefits on soil health?
Yeah, so Brianna, we didn't do water quality studies, which are quite challenging to do because you'd want to measure leaching or monitor the groundwater, which is trying to fill drops in a bucket and measure, the change in that bucket at a giant scale. So it's very difficult to do. I think it's probably reasonable to think that, yeah, if you're going to put on compost and then put on your full fertility program, that you might be losing some of those nutrients in a very sandy soil. But keep in mind, when you increase your soil organic matter is also made up of nutrients, right? So just because you applied it and you didn't see it affected in your tree right away, doesn't mean they were necessarily just lost to the environment. In fact, I have another slide that's demonstrating that. But in general, to build soil organic matter, you're also going to require nutrients to do so. So even if you don't see an effect on the tree within a year or reduced your fertilizers that same year, it's like investing in a retirement fund. You're putting some of those nutrients in the soil organic matter. The question is, how many of those withdrawals are you going to make in the future, and when? And when you do that, how much less income fertilizer do you need to actually sort of sustain the performance of that orchard? So kind of thinking of those different trade-offs as a strategy. But yes, if you apply lots of compost and apply lots of fertilizer, you're going to lose nutrients. So, but I think most growers are smart enough to know, if I'm going to invest in compost, I'd argue all growers are smart enough to know, if they're going to invest in compost, that they're going to probably also be reducing their investment in the fertilizer inputs, because it sort of goes hand in hand.
Thank you, Sat. And I remember seeing a question from Nick and regarding the methods of application incorporation versus surface application. In our project, we did a surface application, and that there's a lot of research need on this application method, how to apply, where to apply, especially in the tree orchards. And so alleys versus close to tree, where also a different irrigation system. So the orchard we worked with had a spray irrigation. And so definitely we need to work with the orchards that have drip irrigation. And so we also on-ground harvesting versus off-ground harvesting. And when we did the surface application and not the incorporation. And so end of season before, at the harvesting, actually some of our compost got scooped up, with our almond industry eventually moving to off-ground harvesting, and then the material compost or pelletized compost or other organic amendment will be able to stay in the soil, on the soil, for undisturbed and by the machinery that handles the harvesting. So that's just comment. We didn't have chance to address when Nick asked that question. But anyway, I know clock is ticking, but do see JP raise the hand again. Definitely wanted to hear from JP again. So
Sure, thanks. Great presentation again today. I thought of something when Dr. Kafka was on, and it occurs to me that I think the feedstock that you were using for your compost, the manure part of your compost, was from separated solids. Maybe a nod from Hossein or somebody to confirm that. Okay. And it just occurs to me, while that is certainly a type of a feedstock from manure that can be used to make compost, when it's gone through a solid separator like the one in the pictures that you have there, you're washing away a lot of the nutrients and they're passing through into the lagoon. And Sat Darshan in his going over his presentation, he talked a lot about the interest, which I really appreciate. First of all, the documentation that food safety was the #1 concern, and that's been addressed somewhat, and that also the next barrier was, one of them was nutrient availability, right? So given this interest in nutrient availability in this compost, it occurs to me that additional research in this area, where instead of using only manure solids that have been separated through a mechanical separator, we can maybe use scraped manure that has been, whole manure that has more of those nutrients in it as a feedstock for this compost. We may see some different characteristics that might make this attractive to folks. That also solves a problem that Stephen Kafka was sort of mentioning, which is, we do have nutrient surpluses on dairies in both the solid and the liquid side, but we can divert using partial scrape. We could divert some of the liquid stream to a solid stream and scrape it, say once or twice a week, and develop a sort of a whole manure stream if we have something good to do with that, such as composting it and pelletizing it, that sort of thing. So I think research in this area that could maybe support that type of a practice and determine if it has better agronomic characteristics for almonds and other crops would be useful in the future. Thank you.
Thank you very much, JP. Very well stated. And I do have a project going and sponsored, funded by California Dairy Research Foundation, and characterizing, working with the different sources of manure on the dairy, And besides the solid separated from the flesh manure, like what we did this with this project, and we also are working with the solids from saline basin, solids from corrals, and some scraped manure. And so and we will be looking into the characteristics, nutrients, and also creating pellets or granules from those source of manure. Just the recent survey of these different types of solids gave us very interesting results. So for example, and the manure on the corral has a lot of higher potassium. That's what that addressed the comment scientists made, and especially for almond trees, almonds, and the potassium is highly valued. And we have found the manure corrals actually have 3-4 times of the potassium than say solids separated from fresh manure. That's very interesting. So research is going to continue, and very much appreciate, also need your support, your great ideas, and so we'll report the results of our new future research as we go. Thank you. Okay, with that, I think it's past the 12, and we could have another hour. However, I think we needed to stop the workshop, conclude our workshop, and and we do have another point or comment in the QA. Let me see, Sad, if you can answer that question in the QA, that would be great. And so I think we'll have to conclude our workshop. I want to thank everyone for joining us, and the panelist speakers and our audience. And we will have final report prepared for this project. And I'm also planning to have a field day sometime in February or early March. And we'll send you the information when we do as we plan, have a date, a select date. And so with that, and also after workshop, we will have a recording, our video recording of our workshop, and I will be happy to share with you, and if and as well as some presentations given today. Thank you very much.
Thanks, everyone.
Thanks, everyone.